How's it grade 12? So I'll be going through exercise 6.4. You guys have asked me to do 1, 2, 3, and 5. Okay, so I've got number 1 here. Let's just read what it says. It says that A, B, and C are 3 points in the same horizontal plane, which I've highlighted blue, which means they're on the flat plane. Then we have that DA is a vertical cliff. Now, straight away, because that's a vertical cliff and this blue part is on the flat ground, I know that this is going to be 90 degrees. Okay. It goes on to say if the angle of elevation from B of the top of the cliff D is theta, and we have that ABC is alpha, and the distance between B and C is K meters. Okay, we need to prove that AD, this length over here, I just want to write it over here, that AD is equal to K tan theta over 2 cos theta. 2 cos alpha, sorry. So that's what we need to show AD is. Now, what I've done here is I've just broken down the 3-dimensional shape into 2D shapes. So I have this ABD triangle, where I know that this is 90 now. And then we have this bottom triangle over here, which is your ABC. That's alpha, and then that's K meters. Okay. Now, what we need to do is we need to find the link between these 2 triangles. And you guys can see that the link is this AB side. Okay, and just remember that this is the side that we want to find, or show that it's that. So what I need to do is I need to link all the information from this triangle into this triangle so we can use it for that DA side. So if I look at this triangle over here, I need to find this BA, all right? And in order to find that BA, I need to look at the information that I have here. I've got the alpha, and the K. So I have the opposite angle to this side, but now you see I don't have the opposite angle for this side here, but I can work it out. I can say that it is 180 minus 2 alpha. And where do I get that from? Well, we've got this angle, and angles in a triangle add up to 180. So 180 minus alpha gives us the 180 minus 2 alpha. All right, so just to put little letters in here so we can use the sine rule. And I know I'm going to be using the sine rule because if I have a look here, I don't have any square roots or any squares. And you'll see in examples later where I can be like, we're definitely using the cos rule here. I know I'm just going to be using the sine rule because there's no square roots or squares. So this is going to be side little a, little c, and little b. And I just want to highlight those for you guys. Okay, so we have to have little c, because that's the side that we want, over sine alpha equals, now we have to have this here, which is little a, which is k, over the angle over here, which is sine 180 minus 2 alpha. Okay. I'm just going to multiply up by the sine alpha, and we get little c is equal to k times sine alpha over. Now, 180 minus is in the second quadrant, and sine in the second is positive, so I can just reduce this to sine 2 alpha. Okay. My little c is AB equals k sine alpha over. Now what we have here is we have a double angle. It's a sine double angle, so I'm just going to expand that. So it's 2 sine alpha cos alpha. This sine alpha will cancel with that sine alpha, and we're left with AB is equal to K over 2 cos alpha. All right, so as you can see with our required to prove, we've got the k at the top, 2 cos alpha, 2 cos alpha. So I'm almost there. I just need to get that tan bit. So that AB is now this AB. Those were the links. Okay, so now I know that this is k over 2 cos alpha. From this angle, that side and this side, you see we have that combination of opposite adjacent. So that is tan. So we've got that AD over this BA will be equal to tan theta. Okay, just multiply up by the BA, and we get that AD is equal to tan theta multiplied by BA, which is this thing over here. So we get that AD is equal to K tan theta all over 2 cos alpha. And that's what they wanted us to prove. All right. Then question B, so this is question A. Question B is just saying that if K is 5 units, alpha is 35, and we've got to calculate AB. So what we need to do now is we need to find out what theta is. And theta is over here. Okay, let's just see how we're going to do this, grade 12s. I think they might have left out some information here. Okay, so what I'll do is I'll just leave this out because they're supposed to give us the K and the alpha and the theta. All right, but normally what you would do, guys, is you just plug your values in here and then you can figure out what it is. It's just calculator work. Okay, right, we are going on to number 2 now. All right, number 2 is saying that we have B, C, and D are 3 points in the same horizontal plane, which I've highlighted in blue. And then it says that AB is a vertical pole. So AB is a vertical pole, and because it's a vertical pole to the horizontal, that will be 90 and that will be 90. And it is P meters in length. Okay, so that pole is P meters. The angle of elevation of A from C is theta. They've also given us that BCD is theta. And then CBD. So we've got CBD is 30. So this angle over here is 30 degrees. And BD is 8 meters. So BD is 8 meters. So what I've done here, and they've just gone to say that we need to prove that P is equal to 4, 1 plus root 3 tan theta, okay, which is this one here. Now, how do I know which triangles to use? Well, I need to use this bottom one, obviously, because it's got some information in there. So that's what I've done here, is I've just drawn it here, and this is 30, and this is 8, okay? Now, how do I know which triangle to use over here, this one or this one? Well, it definitely has to be this one over here because we've got that angle over there. So what I've done is I've drawn the ABC triangle, ABC. There it is with your theta and your P. And then this bottom triangle here, the BCD with your 30 and your theta and your 8. All right. So again, what is the link between these two? We need to find this. The link would be this BC. Okay. All right, so I need to get the information from this triangle onto this side. Once I've got that, then I can link it over there. Okay. So as I can see, I don't really have any square roots or squares. Now, don't look at the square root. Okay, you'll see it is a big square root when we have to use the cos rule. This is just suggesting to me that we're going to be using a special angle because we've got 30 there. All right. So I need this side. In other words, so I'm going to use sine rule. I need this angle over here. So this angle over here would be 180 minus 30 minus theta, okay, because of angles in a triangle. And we get here 150 minus theta. So now I know what this angle is. I've got this angle and I've got its opposite side. So I'm just going to use the sine rule to find that side over there. Again, just put my little letters in. So that's little b, little c, and little d. All right, so we want this. So this is little d over sine this one here, which is 150 minus theta, will be equal to, now we need these two here. So this is going to be, these two over here, which is 8 over sine theta. Okay, just multiply up by that, and we get d is equal to 8 sine 150 minus theta all over sine theta. All right, guys, so what I'm going to do here is I'm going to expand this using compound angles. All right, so we get d is equal to 8 sine 150 cos theta minus cos 150 sine theta. All over sine theta. All right, so I'm going to skip some steps here, guys, just so that you can see and I can put everything on the page here. So 150 is in the second quadrant, and then 150 is in the second quadrant. These ones here, they're already in the first quadrant. I can't reduce them. So sine in the second is positive, but then if I reduce that, that will be 30. Now remember, it's going to be sine 30. So that's a special angle. So I'm going to reduce it to its special angle. So sine of 30 is a half. And we left here with cos theta. Cos in the second is negative. So negative and this negative will give us a positive. If we reduce that 150, it'll give us 30. So cos of 30, again, is a special angle. So we'll get root 3 over 2 sine theta. All over sine theta. Okay, I'm just now going to multiply this 8 in now, and we get 8 times a half is 4, so we've got 4 cos theta, plus, again, the 2 will cancel that, and we're left with 4 root 3 sine theta, all over sine theta. All right, I know it looks horrendous, guys, but just keep to the method and you can't go wrong, all right? Now, I know what the little d is, which is your BC, which is this side over here, okay? Then we want to prove that this side, this P, is equal to that. So from this angle, again, we've got the opposite adjacent, which is tan, okay? So we've got AB, which is P, over this whole thing here, which in this case, I'm just going to say BC, just to save space, equals tan theta, okay? I'm now going to multiply up by the BC. So we get P is equal to, and what I'm going to do here, guys, is because I can see that I need to like cancel the sine theta at the bottom and cancel things over here. I'm going to change this tan to sine theta over cos theta. And I'm going to multiply it by this, because you see I multiply up by the BC, which is this thing over here. So multiplied by 4 cos theta plus 4 root 3 sine theta all over sine theta. Okay, I just want to separate these. Okay, so this sine theta and this sine theta will cancel. Then what am I left with? And I'm going to split this as well. So I've got this 4 cos theta over cos theta. Okay, so I'm splitting it. Plus, then that cos goes over there, 4 root 3 sine theta over cos theta. All right, because the sine's cancelled. This cos and this cos will cancel, and we're left with 4 plus. Sine over cos is tan, so we got 4 root 3 tan theta. What I can do now is I can take out a common factor of 4, and we're left with 1 plus root 3 tan theta, which is what they wanted. Okay, going on to question 3. Okay, so question 3 is saying that TP is a building. All right, now because it's a building, it will be 90 degrees over there. The foot of the building P and the points Q and R are on the same horizontal plane, which I've highlighted in blue. From Q, the angle of elevation of the top of the building is X. Then we have that PQR is 150, and then QPR is Y, and the distance between P and R is A meters. We have to prove that TP is equal to A tan X cos Y minus root 3 sine Y. Okay, sorry for squeezing it in there, guys. All right, so we need to prove that TP is A tan X cos Y minus root 3 sine Y. All right, so we need to show that TP. So this is the one that we want. And the link between these two triangles is this PQ. Okay, so I need to link this information from this triangle into this one. And guys, you can see that I've just broken it down. This triangle is this one is this one. All right, so I can see that I'm not going to be using the cos rule because, again, I don't have any big square roots or any squared. This root 3, that root 3 is going to come from a special angle, okay? So I need this side here, so I need the opposite angle. So this angle here would be equal to 180 minus 150 minus y. So that's going to give us 30 minus y, because angles in a triangle, okay? Right, so this is little q, little r, little p. And we're going to be using the sine rule. So little r over sine big R, which we've just worked out to be sine 30 minus y, equals, and then we're going to have little a over sine 150, because that's our other combination. So we've got a over sine 150. Okay, so if I multiply up over there, I get little r is equal to a. Now, guys, just to save some space in that, you can see that this is going to be a compound angle. All I'm doing is I'm multiplying it up, and I'm going to expand the compound angle. So we get here sine 30 cos y minus cos 30 sine y. All over. And this one I'm going to reduce. It's in the second quadrant, so sine is positive, and then we reduce that to an acute angle. So 180 minus that is 30. So we get sine 30 degrees. Okay. Now, we can reduce these because these are special angles. So sine of 30 is going to be a half cos y minus cos of 30 is root 3 over 2 sine y. And then sine 30 is a half. Okay. So what I'm going to do here again is I'm just going to miss some steps, and that little r is p cubed. Okay, because we're dividing by a fraction, so it's divided by a half, I'm going to tip and times that. So we're basically multiplying by 2, okay? So what I'm going to do is I'm going to multiply in by 2a for each of these terms. So if I multiply that by 2a, the 2's will cancel, and I'm left with a cos y. If I multiply this by 2a, the 2's will cancel, and I'm left with minus root 3a sine y. Okay, so I now have p cubed. So again, guys, we've got this side. We want that side from this angle opposite adjacent, so that is tan. All right, so TP over this PQ will be equal to tan x. Okay, all I'm going to do, that's our PQ, which is this, multiply that up over there. So we get TP is equal to tan x multiplied by a cos y minus root 3a sine y. Okay, I can take out a common factor of a, and I get TP is equal to a tan x cos y minus root 3 sine y, which is what they wanted. All right, going on to question 5. Okay, question 5 is saying, in the diagram, the observation points A, B, and C lie in the same horizontal plane, which I've highlighted in blue. A balloon is situated at P. Now, guys, think about it. If a balloon is directly above the ground, then this would be 90 degrees. Okay, so that means that this would be 90 as well. Okay, is situated at P, which is vertically above C. The angle of elevation of P from A, let me read that again. The angle of elevation of P from A is theta. ABC, so we have ABC is 90 minus alpha. So this here is 90 minus alpha. Okay, which means that this would be 90 minus alpha. And the distance from B to C, is half the distance from B to A, where BA is D units. So this is D, and this would be D over 2. It's half the distance. So this is D, and this is D over 2. Okay. We have to show that H, this thing over here, is equal to this. So let me just write this over here. We need to show that H is equal to D 5 minus 4 sine alpha in a square root all over 2. Okay, again, guys, I don't need to explain how I got the triangles. It's just that one and then that one. Now, we need to show that this side, or this length H, is this whole thing over here. So what is the link between these two triangles? It's this AC side. All right, now this is a perfect example of using the cos rule. How do I know that? Because I have this massive square root. Okay, and that is the only time you will get a big square root like that is if you're using the cos rule. Because with the cos rule, we have all those squareds in it. Okay, and we have all the information here to use the cos rule. We have the side, and the inclusive angle. All right, so it's definitely cos rule, and I'm going to be finding the side over here. So this is little c, little a, little b. Okay, so the cos rule is little b squared will be equal to little a squared plus little c squared minus 2ac cos b. All right, let's just fill in all the information. So little a is d over 2 squared plus little c is d squared minus 2 d over 2 d cos 90 minus alpha. All right, so this gives us d over 4 plus d squared over 4. That 2 will cancel with that, and we're left with minus 2d squared. Now, 90 minus is in the first quadrant. And because we've got 90 there, we've got cocoa as well. All right, so cos in the first is positive, but it'll change to sine alpha. Okay, what I'm going to do next is I'm just going to get an LCD and add all of these things together. So my LCD is going to be 4. So this would be d squared, but that would be multiplied by 4. So we get 5d squared. And then just multiply, this 2 is not there. My bad. Okay, because they're going to cancel. Just multiply that by 4 and we get minus 4d squared sine alpha all over 4. Okay, so just remember that this is little b squared. Now what I'm going to do is I'm going to take the square root, okay, and we'll be left with little b is equal to. So you can see that I can take out a common factor of d squared. Then the square root of d squared is d, and I'm left with the square root of 5 minus 4 sine alpha all over, and the square root of 4 is 2. All right, so that little b is this AC, which is this AC side over here. And we want to find that side there. We got this side, so again, you can see that's a tan, all right? So we'd get PC over AC is equal to tan theta. I'm going to multiply up by the AC, which is this thing over here, and PC is H, so we get H is equal to, sorry guys, I think I got this wrong here, so times by tan theta. My apologies. So multiply up with that, and we get D 5 minus 4 sine alpha square root all over 2 multiplied by tan theta, which is exactly what they wanted. Okay, then question B, it's similar to that question 1. They've just told us that calculate H if D is 300, alpha is 32, and theta is 63. So guys, it's just basically punching on the calculator. They told us that D is 300, so that's 300, the square root of 5 minus 4 sine alpha, they told us was 32, all over 2 multiplied by tan, and theta is 63. So that means that H is equal to, and I'm just going to round this off to 2 decimals, 499,63 meters. Okay, as simple as that, guys. Thanks.